Hey guys, and welcome back to another short and fairly quick video. Now in a previous video, and a whole bunch of other videos, we made this small amount, 1.28 grams, of orthophthalic acid. And this originated from a variety of household materials. It took forever to make, but we finally have it. And this 1.28 grams of orthophthalic acid is going to now be dehydrated into a compound known as phthalic anhydride, which is just the acid hydride of phthalic acid. And of course, only the ortho form decomposes and sublimates into phthalic anhydride. The tera and iso phthalic acid isomers of the phthalic acid will not sublimate the same way. So that's why we needed the ortho isomer. So as you may have guessed, we're going to be producing phthalic anhydride as our product today in this video. So what we're going to first need to do is go grab a large beaker and add all of our orthophthalic acid to the beaker. We will then need to be heating it up very, very hot so that we can decompose it into our phthalic anhydride and water. Also make sure you have a large round bottom flask that fits your beaker, the top of it, which you can fill the round bottom flask with water, so that our phthalic anhydride will condense on the walls of the flask instead of flying out the top, because you don't want to be losing your product. So I'm going to set that all up, go over to our stove, and then I'll meet you back. Okay, so as we heat it up, I just have it cooling right now. But once it's reached room temperature again, we can remove the round bottom flask, and inside you can see all those nice beautiful phthalic anhydride crystals on the side. That's what we're after. There's also some on the bottom of this round bottom flask. We're going to go ahead, carefully remove those with a stir rod, and put them in a small little vial. Then we'll heat this back up, sublimate more of the crystals, and repeat the process. You can just see how beautiful those crystals are on the corner, all lining along the edge of this beaker here. Anyhow, that's basically what we're doing. We're just going to continue that till no more sublimates. As we can see, we have a fair amount of our final crystals, but they are discolored. And this is everything that ended up sublimating, but it does look a bit yellow. So I'm going to be adding this all back into the beaker, resublimating everything, and hopefully be left with some nice pure white crystals instead of these more yellowish ones. Now the purity shouldn't matter too much, but we're just going to double check, just in case. So I'll resublimate everything, and then I'll meet you back. Okay, so after resublimating all of our phthalic anhydride, let's transfer this container, weighed, and you can see we have these beautiful, nice, fluffy crystals of phthalic anhydride, and we have exactly 0.58 grams of it. This corresponds to a 50.9% yield based on the starting orthophthalic acid, which isn't totally great because it was a simple sublimation, decomposition reaction, but we shouldn't have really had any product escaping if our setup was good. I guess what actually must have happened and stuff wasn't fully condensing. A lot of it must have been leaving out of the exit port where the beaker, the lip of the beaker and the round bottom flask was. Must have been leaving out there. I guess when we resublimated it, we must have had some losses there also. And yeah, I don't know, but 50.9% isn't the best, but it's still a decent amount and more than enough phthalic anhydride here to go ahead and produce our phenolphthalein. So, immediately after I'm done filming this, I'm going to be taking some of our phenol, which is really oxidized because we made it about a year ago, because I've been waiting so long and trying so many different ways to make this, a phthalic anhydride, and then we're going to be making phenolphthalein. Now you might have seen other people making phthalic anhydride simply by starting with the phthalate-based plasticizer from vinyl gloves. And I tried this so many times with so many different brands of gloves. And while the procedure worked exactly as other people had described it and done it and everything, the product was definitely not orthophthalic acid, although I believe it was some sort of phthalic acid. Probably the tera isomer or the isoisomer, so terephthalic acid or isophthalic acid. That's probably what it was, just because it wasn't soluble in water and wouldn't react with phenol to form phenolphthalein. So I gave up on that approach altogether and had to restart right back from zero, trying to get phthalic anhydride from household materials, and it looks like the oxidation of xylene is a guaranteed method to produce phthalic anhydride no matter what, because xylene has a guaranteed content of 20% orthoxylene. So, nonetheless, I greatly prefer this method over trying to extract it from vinyl gloves. It just works far better and everything. So, yeah, hopefully we'll be making some phenolphthalein in a future video, and hopefully it's going to work. Yeah, so, I'll see you guys in another video. Bye.